If you can dream it, you can build it. Dream of designing a device that will change our lives. Now imagine you can make it happen. Make it real. Make it fast and powerful. Make it intelligent and make it learn. Make it analyze and predict. Make it fun and creative. Make it look sharp and gorgeous. Make it friendly, user-friendly. Make it efficient and productive. Make it smart and connected. Make it prevalent and extensive. Make it secure and protected. Make it safer and autonomous. Make it sound clear and pure. Make it speak
and understand.
Make it free, truly wire-free. Make it sweat and stay in shape. Make it move and sense all around you. Make it grow and make it nourishing. Make it all happen with Ceva. Ceva licenses ultra-low power smart sensing and wireless connectivity solutions. Ceva's IP powers more than 10 billion devices worldwide. Dream it and make it with Ceva.
With that, I'd like to move to the next lecture by Ben Weiss, who will talk about adaptive processing of wide-angle cameras. Ben, please.
Okay, thank you, Moshe. So welcome, everyone. Thank you for joining us today. My name is Ben Weiss, and I'm working with Ceva as a vision expert in the Customer Solution Group. Today, I would like to present Immervision technology for wide-angle image and video processing. Less than a year ago, Ceva entered into a strategic partnership with Immervision. As part of this partnership, Ceva has the exclusive licensing and distribution rights for Immervision Advanced WideAngle SDK. We will start with the motivation. Why do we need to integrate wide-angle camera in a device? What are the advantages and the challenges comparing to a standard narrow-angle camera? Then, we will cover some basic technical terms that will help us to fully understand Immervision technology. In the next topic, we will describe in details the optics and the software solution provided by Immervision. First, we will describe the partnership between the two companies, and then we will move to the optics solution as well as the three main software products provided by Immervision: adaptive dewarp, 360 image stitching, and data in picture. So why do we need a wide-angle camera in our device? For the last couple of years, we can see a clear market trend related to wide-angle cameras. More and more OEMs prefer to integrate a wide-angle camera over the standard narrow-angle camera. All the leading smartphone OEMs have at least one wide-angle camera in their products. All modern cars have at least one wide-angle camera. Ultra-wide-angle lens are used in the video security market, and 90% of the drones and all action cameras use wide-angle cameras. The wide-angle camera provides a visually appealing imagery results. Using the wide-angle camera, the user can get an image which is much closer to the one captured by a professional camera. For smartphones, the wide-angle camera can be used to create a panoramic view or to capture a selfie or a groupie with a much wider field of view. For surveillance, drones, and action cameras, using wide-angle camera and a dedicated software or hardware enable us to provide a unique and immersive experience like the 360 video we will present later on today. Another reason to integrate a wide-angle camera in the device is to collect more information about the scene with a single static camera. In the surveillance market, collecting more visual information from a single camera helps us to secure the environment while reducing the cost of installing multiple cameras to cover a large area. In the IoT and smart edge devices, we try to keep the cost as low as possible by integrating only a single camera in the device. Integrating a standard narrow-angle camera will limit the amount of data the device can collect, sense, and analyze. Therefore, we can see more and more OEMs deciding to integrate a wide-angle camera over a narrow-angle one. In these use cases, more visual data means a smarter device with a better contextual awareness. The wide-angle camera enables to have a much better understanding of the scene and to track the user activity regardless of his location. In the automotive industry, as well as the AR/VR headsets and drones, wide-angle cameras can improve the device motion sensing. Integrating visual data from multiple sensors is used to determine the device location and orientation in an unfamiliar environment. Wide-angle field of view provides more information about the ego motion of the device and can improve the accuracy of the navigation task, or to get much better synchronization between the AR/VR content and the real world. Wide-angle technology basics. One of the basic elements we need to learn to fully understand Immervision technology is the field of view, or FOV. Field of view describes the observable area a person can see through his eyes or a camera can capture through the lens. For example, the human visual system can collect three-dimensional data using two eyes with FOV of 114 degrees. Two-dimensional data can be collected using only one of the eyes and enables a wider FOV of 210 degrees. This way, we can spot objects or people located slightly behind us. Diagonal FOV is the way we measure the FOV of a camera. Diagonal FOV is the distance between the top left corner and the bottom right corner of the image. Wide-angle lenses are lenses with an FOV of more than 80 degrees, comparing to the standard narrow-angle lenses with a 60 to 80 degrees field of view. As you can see on the left side of the screen, the narrow-angle camera limits the amount of data we can collect and therefore provide only part of the story about the scene. In this example, we can see only a little girl in a ski site. By moving to a wide-angle camera or even ultra-wide-angle camera of 190 degrees, we can see that the girl is with two other ladies. Fisheye lens is a unique type of ultra-wide-angle lens with linear mapping between the angle of the light and the number of pixels. One of the side effects of integrating a wide-angle camera in a device is the radial distortion. The radial distortion makes the lines in the real world to appear as curves in the image domain, and objects lose their proportion as we move from the center of the lens to the edges. There are types of radial distortion: positive radial distortion, or barrel effect, and the negative radial distortion, also known as the pincushion distortion. Another side effect related to wide-angle lens is the brightness and color artifacts in the edges comparing to the center of the lens. Immervision provides a de-warp module to fix the radial distortion. De-warp is a process used to remap the pixels in the image and fix the radial distortion. Pincushion de-warp, also known as rectilinear or perspective de-warp, is the classic and standard way to correct the distortion and to make sure the lines are straight after processing the image. Lines in the real world will appear as lines in the image, but objects will lose their proportion through the process. This version of de-warp is better than capturing buildings or urban spaces, but it's not so good to correct faces, for example. Groupie de-warp, also known as the equirectangular de-warp, is the way to correct the distortion of faces by preserving objects' proportions. Color and shading correction can be coupled together with a de-warp process to reduce the bandwidth and improve the overall performance. Immervision provides an adaptive de-warp that can correct both the lines and the faces. As you can see on the top of the screen, using the pincushion configuration, only the lines are straight, but the faces are completely distorted. In the bottom of the screen, using the groupie configuration, only the face or the body proportions are preserved, while the lines in the background are curved. On the right side of the screen, using the unique algorithms provided by Immervision, the adaptive de-warp, can be used to correct both line and faces proportion in real time. Immervision are experts in lens design, and they use their knowledge to tune the software and reach the best imaging quality for any given lens. The software is fully adaptable to the scene. Different scenes mean different de-warp configurations that the user or the neural network can select in real time according to the content. Immervision technology. Immervision is a Canadian company located in Montreal. The company develops and licenses wide-angle lens and image processing software for wide-angle cameras. They have patents for optic designs as well as algorithms to dramatically improve the wide-angle quality. Ceva is now the exclusive distributor of Immervision software. Ceva's main business is DSP IP, so all Immervision technology is now available on Ceva XM4 and Ceva XM6 intelligent vision DSPs, but the software can efficiently run over CPU as well as GPU. Immervision offers a wide-angle optical solution as well as WideAngle SDK. The WideAngle SDK includes the adaptive dewarp we discussed a couple of minutes ago, as well as the 360 image stitching technology and the data in pixel for sensor fusion. All the software stack can be executed with a real-time performance and very high quality, both on CPU, GPU, and Ceva DSP. Panama flans is one of many Immervision patents. This design can improve the optical performance in predefined regions of interest or in the whole image. It improves all the quality metrics from the center of the lens to the edges, the pixel density, the MTF, and the relative illuminance. On the right side of the screen, you can see a standard fisheye lens with a linear mapping of pixels to angles. As you can see, the edges of the image are pretty distorted and it's very hard to read the text on the box, while the resolution on the center is pretty high. Using the Panama lens, as can be seen on the left side of the screen, the mapping between angles and pixels is not linear anymore. This way, we can get a much better resolution on the edges comparing to the center of the lens. Now, the text on the box is clear and we can easily read it. By shaping the lens, we can customize the optical solution to perfectly fit the customer needs. By combining the optical solution together with the software solution, Immervision can provide an end-to-end solution for the customer. The software solution provided by Immervision in the WideAngle SDK includes 3 main products as well as additional features. The main products are adaptive dewarp, 360 image stitching, and the data in picture for sensor fusion. Additional features can be combined with each one of the products and includes also color and shading correction, image stabilization, image fusion, and multi-image sensor fusion. The leading product is the adaptive dewarp, and it's the core technology of all other Immervision products. The adaptive dewarp, as explained before, can fix both lines and faces distortion, as well as the color and shading artifacts. The algorithm is fully customized for any type of lens selected by the OEM, as well as the customer's specific requirements. Immervision provides the best-in-class dewarp solution that improves both lines and face proportion while keeping a maximal field of view at the generated output. The algorithms can be used for live preview as well as image or video capturing. Using Immervision technology, what you see is what you get. The live preview on the screen before clicking the button will look exactly the same as the captured image in the memory of the device. No need to recapture the image since the face looked different before and after clicking the button. This feature can only be achieved by integrating Immervision ultra-fast dewarping solution. All products are hardware agnostic and platform independent. We can run the algorithms on CPU, GPU, and Ceva DSP, and the software is available for Windows, Linux, Android, and iOS. With a 5G network, users will consume more and more high-resolution videos in real time. In this demo, Ceva presents how Immervision technology can be used to create a new 360 video experience for the 5G-enabled smartphones. So this is a real-time processing of a 4K video captured by a 360 camera and reprojected to the smartphone screen with a very short latency. The original 360 input video can be streamed from the 5G network or from the camera, and the user can navigate using his finger in real time inside a 360 video and create his own personal point of view. These demos show how fast and flexible is the adaptive DWORP solution provided by Immervision and how we can create a new immersive video experience for 5G users. The 360 image stitching product can be used to stitch videos from multiple cameras and combine them together into an impressive 360 video stream in real time. In this demo, we will show how a front and a back ultra-wide-angle cameras can be used to create a 360 image in real time, and the different ways we can shape the 360 image to create a unique experience for the smartphone user. Thank you, Moshe. So the last product is the data in picture. The data in picture is a patent Immervision developed to solve the synchronization issues between the video stream and the other sensors at the edge device like IMUs, GPUs, and more. The sensor's data can be synchronized and encoded inside the video file at the edge device and decoded at the remote display device. Immervision decided to represent the sensor data as a QR code embedded at the four corners of the video file. The QR code is used to preserve and protect the sensor data through the image pipeline and common video compression algorithms. The OEM can select to encode pre-configured sensor data or to integrate his own custom metadata files into the QR code. This way, the video frames and the metadata from all sensors will arrive at the same time to the remote display.